Okay, in this video, we are going to discuss what is microcontroller addressing and what are the types of addressing modes and how the addressing modes are classified. These are all the things we are going to discuss in this video. First of all, what is addressing mode? What is addressing mode? See, each instruction requires certain data which it has to operate. There are various techniques to specify the data. The techniques are known as addressing mode. Means that each and every instruction having certain addressing modes. Just a moment. Means that each and every instruction having certain data, because the operation can be performed with this data. So data is essential for addressing mode. The way of representing the data, how to specify the data is known as addressing modes. Okay, see in the other definition, the way of representing data are also known as addressing modes. See, the CPU can the CPU The CPU can access data in many ways. The data could be in a register or in a memory. To be provide an immediate value, the way these ways are known as addressing mode. Actually, the CPU can having some data. The data are to be maintained in a register or in a memory. The way of representing the data is known as addressing modes. Actually, the addressing modes are classified in many ways. See the types of addressing mode. In this addressing modes are majorly classified in 5 categories. They are immediate addressing mode, register addressing mode, direct addressing mode, and then indirect addressing mode. Actually, it is a register indirect addressing mode. Then last one is indexed addressing mode. These are all the classifications of addressing mode. Means that addressing mode in the sense the way of representing data is known as addressing mode. Each instruction requires certain data which it has to operate. There are various techniques to specify the data. The techniques are known as addressing mode. Clear? Addressing modes are classified in 5 categories: immediate addressing mode, register addressing mode, direct addressing mode, indirect addressing mode, and last one is indexed addressing mode. We will see one by one. First one, immediate addressing mode. In this addressing mode, data is a part of the instruction. Data is a part of the instruction. See, the source operand is a constant. The immediate addressing mode, as the name implies, when the instruction is assembled, the operand comes immediately after the opcode. Here, the data must be preceded with a pound sign. Clear? Data is the part of the instruction. Data is immediately moved to the CPU register. The data can be processed by the symbol hash. It is not symbol hash, it is known as pound. The symbol is known as pound. See the examples. See here, move R0, 21. the value, immediate value 21 is immediately transferred to the register R0. Okay, so the R0 value, R0 register contains this 21 value. After execution of this instruction, R0 register contains the value of 21. So the immediate data is immediately moved to the CPU register. See here, move A comma hash 26H. Here the immediate value 26 is moved to the accumulator. A in the sense accumulator. These are all the examples of immediate addressing mode. Then the next one, move DPTR comma hash 2100. DPTR is a 16-bit register, so it may contain 16-bit value. The 2100 can be known as, it is known as a 16-bit value. The 16-bit value is immediately transferred to the DPTR register. Next, register addressing mode. The register addressing mode involves the use of registers to hold the data. We are not bothered about the register content. See, the data manipulation process within the register are known as register addressing mode. Data manipulation process within the registers are known as register addressing mode. See the example, move A comma R0. Here we are not bothered about what are the contents of accumulator, what are the contents of R0 register. Then we directly process the registers, directly process the data by using this registers. These kind of instructions are known as register addressing modes. See the another example, move A comma B. Here the accumulator content is directly moved to the, B register content is directly moved to the accumulator. So here we are not bothered about the accumulator content and B register content. We are manipulating the registers. We are manipulating the data by using the registers. See, internal data transfer is not allowed. Means that the data transfer within the registers are not allowed. Okay, what are that? See, move R0 comma R2. Move R0 comma R2. The same bank registers, it is not allowed. Move R0 comma R2 in the sense it is invalid. Move R4 comma R7. These are all the registers within the same bank, so it is not allowed. Internal data transfer is not allowed in the 8051 microcontroller. See the next one, direct addressing mode. In this direct addressing mode, data is directly moved to the CPU register. What it means? Data is directly moved to the CPU register in the sense the CPU register are given in the form of RAM address, direct address. RAM address is known as direct address. Data is moved to the direct address. So data is immediately moved to the register, RAM register by using the direct addressing mode. See, here the data is a part of the, direct address is a part of the instruction. Clearly mentioned that data is directly moved to the CPU register. Here the CPU registers are mentioned in the form of RAM address. Means that RAM address is a part of the instruction. RAM address is the part of the instruction. I will give you some examples of accumulator, B register, RAM address. Accumulator RAM address is E0. B register RAM address is F0. DPH RAM address is 82. DPL RAM address is 83. Port 0 RAM address is 80. Then port 1 RAM address is 90. Port 2 is A0. Port 3 is B0. Stack pointer is 81. Which will help you, these RAM address are important one, which will help you in to identify the RAM address. See, I will give some examples like move E0 comma 21. What it means? Move E0 in the sense it is mentioned that accumulator RAM address E0 is mentioned that accumulator RAM address. It can be written in the form of normal equation, normal immediate equation like this. Move A comma 21. Both the equations, both instructions are same, but it can be written in the form of direct addressing mode. Move 82, hash 27H. Here the 27H is directly moved to the 82H. 82 in the sense 82 is known as DPH. So the value 27 is moved to the DPH. Next, move A, F0. What is F0? F0 is the RAM address of B register. See, this instruction can be written in the form of normal equation. Move A, B. It is an example of register addressing. But move A, F0 is an example for direct addressing. Why it is direct addressing? Here the B register is directly given in the form of RAM address. B register is directly given in the form of RAM address. Next one. See, move 5, A. Is this one instruction is right or not? Yes, it is right, because 5 in the sense move R5, A. 5 in the sense it is R5. 5 in the sense it is mentioned in the R5 instruction. Then next, see, indirect addressing. It is an important concept. See, in this addressing mode, it is used for internal data transfer. Internal data transfer. What is internal data transfer? Data transfer within the registers are known as internal data transfer. Here this addressing mode will help you to move the data within the register by using this indirect addressing mode. See, registers R0 and R1 are to be employed for this purpose. Only R0 and R1, clearly mentioned that R0 and R1, no other registers are used for internal data transfer or indirect addressing mode. Okay, register R0 and R1 is used for this indirect addressing mode. Okay, then next, the symbol at is indicate the indirect addressing. Actually, the symbol pound, hash symbol is used for immediate addressing mode. The symbol @, is used for indirect addressing mode. Here the @ symbol is used for indirect addressing mode. This can be used to distinguish whether you are using indirect addressing mode or direct addressing mode, which will specify the indirect addressing mode. Clear? See, for an example, move @rate of R0, A. Move @rate of R0, A. This can be explained by using some other program like this. See, move R0, hash 25H. Suppose I am moving the immediate value R0, 25H. That value 25H is moved after the execution of this instruction. The value 25H is moved to the R0 register. The value 25H is moved to the R0 register. Then next instruction, move A, hash 5H. This is the example program, but don't confuse with the example. This is the example program. Okay, move R0, 25H, move A, 05H. After execution of this instruction, A contains 05H. Okay, then suppose consider the values. Consider the memory values 24, 25, 26, 27 are the address which may contains the values of 82, B4, C2, 36 like that. Likewise, after the instruction move @rate of R0, this is the example for indirect addressing. This is the example for indirect addressing mode. After execution of this instruction, that is move @rate of R0, A, then the value of 05 is transferred. The value of accumulator is transferred R0 defined location. R0, here R0 is 25. 25 is taken as an address. Go to that address and swap the value. That is 05 is transferred to 25H. In the address 25H, the value of 05 is transferred to 25H. Okay. Then next, move F0, @rate of R1. Here the R1 value is taken as an address and go to that address and take the immediate value to transfer to F0, that is B register. Okay, here this instruction is known as indirect addressing mode. I am explaining one more thing, one more time. See, move R0 comma 25H. After the execution of this instruction, R0 having 25H value, move A comma 05. After execution of this instruction, A contains 05 value. Move, consider the memory locations 25, 24, 25, 26, 27. Here 25 having 25 memory location 25 having value of C2. Then move at rate of R0 comma A. After execution of this instruction, the value 25, the address 25 value C2 is transferred to 05. Okay, in this way, this instructions, this indirect addressing mode will work. Okay, next one, indexed addressing mode. Indexed addressing mode. What is indexed addressing mode? Data is defined in the form of indexing. Data is defined in the form of indexing. What is indexing? Here, the indexing means listing. The listing data are formed in the listing format. This can be used in C or X. C is known as code memory. C is known as code memory. X is known as external memory. Code memory, in the sense, it is known as internal data memory. Internal memory. It is not ROM, it is RAM. Internal memory. X, in the sense, external memory, it may ROM or RAM, whatever it is. External memory, it is simply called as external memory, whether it is a ROM or RAM, whatever it is. Okay, then data pointer or PC is used for indexing with the accumulator. Data pointer, this type of instructions may contain only DPTR or PC. C, move C in the sense code memory, A comma at rate of A plus DPTR. At rate of A plus DPTR. I am explaining this instruction by using some program. See, first one, example program. First one, move R0 comma 05. After execution of this instruction, R0 register having the value 05. Next, move DPTR comma hash 500H. After execution of this instruction, DPTR contains 500H. Clear A. Clear A, in the sense accumulator content gets cleared. Move C, A comma at rate of A plus DPTR. What is A plus DPTR? What is A plus DPTR? A content is 0, then DPTR content is 500. So A plus DPTR, in the sense it is 500. It is taken as an address because at rate symbol indicates that it is address. So 500 is taken as an address. 500 is taken as an address. That value is transferred to accumulator. A2. See, A2 having value of 500. 500 address value is F2. That F2 is transferred to accumulator. Next, move P1 comma A, that is accumulator content is transferred to port 1. This is the use of that application. We can index the data while processing. The data comes one by one. See, increment data pointer. Increment data pointer. Increment data pointer, in the sense data pointer content is incremented by 1. What is the data pointer content? Data pointer content is 500. So 500 is incremented by 1. It is 501. Then DJNZ, decrement, jump non-zero. Decrement, what is the value of R0? What will be decremented? The R0 content gets decremented by 1. If it is not 0, then jump to the loop. DJNZ, in the sense decrement, jump non-zero, R0 comma loop. What is the value of R0? 0, 5 is the value of R0. Then R0 value is decremented by 1, 0, 4. Is it is 0? No, it is not 0. So jump to the location loop. Then again clear A. Accumulator content is cleared. After clearing the instruction, move C A comma A plus DPTR. What is the DPTR content? 501. So 501 plus 0, that is 501. The 501 is taken as an address. That value is transferred to accumulator. After execution of this instruction, 501, that is 44, is transferred to accumulator. After transferring this accumulator, that value is moved to the port 1. Here we can get all 5 values. That is 500, 501, 502, 503, 504. Likewise, we can get the instruction. Okay, I am explaining one more time. See, this example I can explain one more time. See, move R0, 05H. The 05H is transferred to R0. After executing this instruction, R0 value is 05. Then move DPTR, hash 500H. So the data pointer content is 500. Then clear A. Accumulator content gets cleared. Accumulator content gets cleared. See, move C A, at rate of A plus DPTR. A plus DPTR in the sense, what is A plus DPTR? A accumulator content is 0, data pointer content is 500, so 500 is a plus DPTR content. At rate symbol indicates that it is taken as an address. So consider this memory location 500, 501, 502 likewise. The 500 data is transferred to accumulator. Okay, 500 is taken as an address. Go to that address, take the data, that is F2 is the data. That data is transferred to accumulator. Then if the data is transferred to port 1, move port 1, A. Means that the accumulator content is transferred to port 1. Okay, then increment data pointer. What is increment data pointer? Data pointer content gets incremented by 1, that is 501. DJNZ R0, decrement R0. First decrement R0. What is the content of R0? R0 content is 05. Here 05 is decremented by 1, that is 04. The 04 is transferred to R0. If it is 0, is it 0? No, R0 having the content of 04, so it is not 0. If it is not 0, jump to the location loop. So loop location is jumped. Clear A, again clear A, move C A, A plus DPTR. Here the DPTR content is 501. So data pointer plus 501 in the sense 501. Go to that location 501. Value in that location, value is 44. That 44 is transferred to accumulator. After accumulator, the data is moved to port 1. Likewise, we can access these 5 locations. Clear? These are all about addressing modes. I am explaining one more time. Addressing modes. Addressing modes are known as each and every instruction requires data which it has to operate. There are various. How to specify the data is known as addressing mode. Actually, you are having certain name. Name itself as address to identify that particular person. Okay, the way of representing data is known as addressing modes. Okay, types of addressing mode. What are the types of addressing mode? See, addressing modes are classified in 5 categories. They are immediate addressing mode, register addressing mode, direct addressing mode, indirect addressing mode, and indexed addressing mode. First one, immediate addressing mode. In this immediate addressing mode, data is a part of the instruction. Data is part of the instruction. See, data is immediately moved to the CPU register. Data is immediately moved to the CPU register. Here the symbol pound is known as used to this symbol pound is used to distinguish from the other addressing mode. If the symbol pound is identified in a particular instruction, in the sense it is known as immediate addressing mode. Then example, see, move R0 comma hash 21H. That 21 value is moved to the R0 register. Move A comma 26H. In this value, that is 26, is moved to the accumulator. Then move DPTR comma hash 21H. Register addressing mode. In this addressing mode, the data manipulation between the registers are known as register addressing mode. Data manipulation between the register are known as register addressing mode. Move R0 comma A. See, move A comma B. Here we are not bothered about R0 content and the accumulator content. We directly process through the registers. Internal data transfer is not allowed. Means that internal data transfer means that it is within the bank, the internal data are transferred within the registers are not allowed. Like the move R0 comma R2. These are all having the same bank, so it is not allowed. Move R4 comma R7 is not allowed because it is within the same bank, so it is not allowed. It is not allowed. Direct addressing mode. In this addressing mode, data is directly moved to the CPU register. CPU registers given in the form of RAM address is a part of the instruction. RAM address is a part of the instruction. In that addressing mode, we are specifying certain values, that is accumulator E0, B register F0, DPH 82, DPL 83, port 0 80 and port 1 is 90. Likewise, we are giving some RAM address for registers. For example, move E0 comma 21. E0 in the sense it is accumulator, so this can be written in the normal form, move A comma hash 21. Here A is indirectly given, that is directly given, means that E0 is a direct address of accumulator, 82 is a direct address of DPH, and F0 is a direct address of B register, 5 is direct address of R5. These are all the examples of direct addressing mode. Indirect addressing mode. In this addressing mode, internal data transfer is possible within the registers. Move R0 comma R1 is processed in this instruction. The symbol attrite is used to indicate the address, indirect address. For example, move attrite of R0 comma A is directly, accumulator content is directly transferred to the R0 register. For example, move R0 comma 25, the value of 25 is transferred to R0 register. The move accumulator comma hash 05, the 05 value is transferred to accumulator. Consider this listing table. In this listing table, the R0 value is taken as an address, that is 25 is taken as an address. In that address, value C2 is changed to 05, accumulator content, move attrite of R0 comma A. Then another one example, move F0 comma attrite of R1. What is the value of F0? What is F0? F0 is a RAM address of B register. Then next one, indexing, indexed addressing. Indexing, data is in the form of indexing. Indexing in the sense listing. Okay. The letter C or X are to be used for this indexed addressing mode. C in the sense it is code memory, that means internal memory. X in the sense it is an external memory. Then C and X are to be used. Here data pointer or PC may be used for indexing with the accumulator. For example, move C A comma attrite of A plus DPTR. A plus dptr, I'm explaining this A plus dptr in some other program. Move R0 comma hash 05. The value 05 is transferred to R0, and then move dptr comma hash 500h. The value 500h is transferred to data pointer. Then clear A, accumulator content gets cleared. Move C, A comma at A plus dptr. A plus dptr, what is the value of A plus dptr? A content is 0, dptr content is 500. So A plus dptr in the sense 500. Consider the memory location 500. In that 500 value, 500 address, we are having value of F2. That value of F2 is transferred to accumulator. Then accumulator value is transferred to port 1. Increment data pointer is incremented by 1. So data pointer value is incremented by 1, that is 501. Then djnz r0 comma loop, or djnz r0 comma loop in the sense decrement the value of r0. Decrement the value of r0. What is the value of r0? 05 is the value of r0. Then r0 value is decremented by 1, and then it is not 0, so jump to the loop, clear A. Again the process is going on. Next, instruction set classification. How the instruction set is classified? See, instruction set are classified based on the performance is 5 types. They are arithmetic instruction. What is arithmetic instruction? Addition, subtraction. See, add A, sub B, multiply, division. These are all the instructions for arithmetic process. So these instructions are known as arithmetic instructions. Next, logical instructions. What is logical instruction? Logical instructions are doing some logical operations like AND, OR, complement, rotate. These are all the logical instructions. Next one is branching instruction. What is branching instruction? See, A call, absolute call, L call, long call, A jump, L jump, absolute jump, S jump, simple jump or short jump, L jump, long jump, JC, jump no carry, JC, jump carry, jump no carry, compare, CJNE, compare jump not equal, compare jump not equal, CJNZ. These are all the instructions for branching. That means flow control is branched to some other instruction, that is called branching. These instructions are used to branch the flow control. So these instructions are known as branching instructions. Next one is data transfer instructions. Data transfer in the sense data is transferred to here and there. That means within the CPU registers or memory location, data is transferred by using some instructions for data transfer. By using these instructions are used to transfer the data within the registers and the memory location. So these instructions are known as data transfer instructions. Bit manipulation instructions. See, bit manipulation, bitwise manipulated instructions, bitwise. So it is clear, set bit. These are all the instructions for bit manipulation. I am summarizing this instruction set. Instruction set is classified based on the performance. It is classified in 5 categories. They are arithmetic instructions, logical instructions, branching instructions, data transfer instructions, bit manipulation instructions. Arithmetic instructions in the sense arithmetic process, addition, subtraction, multiplication, division. These are all the instructions to be used for arithmetic process. So these instructions are known as arithmetic instructions. Logical instruction, logical operations like AND, OR, complement, rotate. These are all the logical instructions. Branching instruction, the flow control is branched to one end to another end. That is called branching instructions. By using these instructions, we can branch the flow control. So these instructions are known as branching instructions. Data transfer instructions. Data transfer instruction, data is transferred to within the registers or memory location. These instructions are used to transfer the data within the memory or registers. So these instructions are known as data transfer instructions. Bit manipulation instructions. These instructions are to be used to manipulate the bits. So these instructions are known as bit manipulation instructions. For example, clear, set bit. These are all the instructions for bit manipulation. Okay, these are all about instruction set classification. Okay, I wind up this session. Okay, thank you. Thank you.